I'm rather surprised that it happened in my lifetime. I certainly had no idea that it would happen in my lifetime at the beginning more than 40 years ago.
I think there could be worse days in the life of a Director General, I must say. I think we have a success today. We have a discovery. We have discovered a new particle, a boson, most probably a Higgs boson, but we have to find out which kind of Higgs boson this is. Does it have the properties which we expect from the standard model? If not, what are its properties and where do they point to? We have now found the last missing cornerstone of it, I think. And this is why everybody is not only excited about the discovery, everybody is also excited about the prospects this discovery opens for us, for the field, and for physics in general.
This boson is a very profound thing that we found. Okay, this is not like other ordinary particles. It really is. We're reaching into the fabric of the universe at a level we've never done before. This is telling us something. It's a key to the structure of the universe. It could be the final point in the standard model, but we know at some level we're pretty sure that the standard model is not the full picture. So we've kind of completed one part of the story, if you like, and we're on the frontier now. We're on the edge of a new exploration. And this could open up, maybe we see nothing extraordinary, and we understand that maybe this is the only part of the story that's left, or maybe we open up a whole new realm of discovery. But we're way out on the edge of understanding. We don't know. This is exploration.
The nice thing of research is that you don't know how quickly you can get some goal, and you're looking for something, and if what you find is exactly what we were looking for. Sometimes the answer is totally different. Okay, so now we observe something, we see a signal. We think it is very close to what we expect from what we know, the Higgs or the standard model Higgs, but we don't know the detail. We will have to scrutinize this signal, and then let's see. It can take 1 year, it can take 4 years, it can be a long path, because in the meantime we find something else, and this something else will contribute to the understanding of the global picture. So the picture may be much more complicated than what we've seen today. I hope it will be much more complicated than what we've seen today.
For the other laymen out there, about 6 billion of them, what does this mean? We've heard that if it is the Higgs, it explains why we have mass. Is that your best shorthand explanation for the rest of us of what this means? And if we didn't have an explanation, and did we really not have an explanation before this of why we had mass?
I think I first have to correct, with all respect, with Peter Higgs and the other theory colleagues here, it's not what gives you the mass. That's different. That's a different mechanism. If it's a Higgs boson, what this Higgs boson would tell us is that there is a certain field out here, everywhere, a certain field through which the fundamental particles, like the quarks, the bosons, get their mass. It's not that you get your mass. How can you imagine that this thing works? Well, you take a large room with journalists, okay? And they are all equally distributed in the room. This is the field which would give mass to elementary particles through the interaction of these particles with the field. Somebody who is completely unknown to the journalists can go through this field, through the journalists, with speed of light. That means that person would have zero mass. The more known you are, the more journalists are clustering around you. That means you get slower, you don't reach the velocity of light, you acquire mass. The better known you are to the journalists, the more massive you are. Okay? You saw this when you were coming in here, yeah? Peter Higgs was pretty heavy. Huh? Okay? Now that doesn't tell you anything about this boson yet. But this field, as the journalists obviously, has an interaction in between itself, and this self-interaction can produce this Higgs boson. How can I imagine that? Imagine I open the door and I whisper a rumor into the room. Then the journalists are curious, they cluster. What did he say? This cluster of journalists is the Higgs boson. That's easy. That's particle physics for laymen without a single equation.
That's very, very good, thank you. But to the extent that I am made of fundamental particles, does this not have any relevance to me?
I think it has a lot of relevance to you, because if that would not exist, I think you would not exist.
I think it's extraordinary that they have opened CERN up and these projects to all countries in the world. And that's a magnificent thing, because these results are now global and shared by all of mankind, I think. So I thank you for that. Sure.
I would like to inject here a personal remark. I take full responsibility of this remark. It is very nice of the standard model Higgs boson to be at that mass. Because at that mass we can measure it at LHC in huge number of final states. So, thanks nature. So, this is our main result. And I would like to mention that these accomplishments are the results of more than 20 years of hard work, extreme dedication, and very talented ingenuity of the Atlas collaboration, with the continued support of the funding agency that I would like to thank. But more in general, I think these results are the outcome of the ingenuity, vision, and painstaking work of our community, from accelerator to detector, instrumentation, computing, and physics. I think we all have to be proud of these results, and I hope that they open a door toward a very bright future. Thank you.